Hey, you should be open to page 57 in your workbook, so talking about square roots today. Um, Hopefully you guys remember how to do this. First of all, we need to remember what an exponent is. So an exponent tells you how many times to multiply a number by itself. So 3 here would be our exponent, so it's a really tiny number. The base is the number that's getting multiplied, so 10 would be our base in that problem. So 10 to the third power, or 10 cubed, would mean 10 times 10 times 10, which is 1,000. If it's a number times itself, we say that it's squared. So if the exponent is 2, that means squared, or you can say to the second power. But most of the time, we'll say squared. So 6 squared means 6 times 6, which is 36. So we would say 36 is a square number because we squared a number to get it. We did 6 squared to get 36. Now, on the flip side of squaring a number, there is something called a square root, which looks like a division sign, but it's called a radical sign. So here, this little symbol right here, that's called a radical, which means the square root of. So if you see the square root of 49, you're thinking what number times itself, or what number squared is 49, and we know that that's 7. If the square root of a number is an integer, so a whole number, this is called a perfect square. And they gave you a chart over here. Part of it's cut off, but it's at the top, where it just lists your perfect squares for you. So 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, and it just goes down the line. So all of your whole numbers squared. And then we can easily take the square root of those and get a whole number. Okay, so please turn to page 58. And page 58 says, think about it, explain why all numbers are not perfect squares. So the reason is if you want to find, say, the square root of 5, there is no whole number, so it specifically needs to be a whole number. That's awful. Okay. Whole number. My pen is being awful right now. There's no whole number that you can multiply by itself to get 5. So, like we know, 2 times 2, that's 4. The next whole number would be 3. 3 times 3 is 9. So it just passes 5 altogether. So it will do that every once in a while. We can't always get a whole number as our answer. Moving down a little bit, they want us to figure out which of these numbers are perfect squares. So in order to do that, we want to find the factor pairs for each of these. So I need to think what number times what is going to give me 100. So I know that 1 and 100. So 1 times 100 is 100. I know 2 times 50 is 100. I know 10 times 10 is 100. I'm not going to list them all. What I'm looking for is I want to get the same number. So here, 10 and 10, same number. So that's what I'm looking for. For 2, we can do 2 and 100. We could do 4 and 50. We could do 5 and 40. We could do 1 and 200. But I can't think of any number times itself that's 200. For 3, I can do 3 and 100. I can do 1 and 300. I could do 30 and 10. But again, I can't think of a number times itself that gives me 300, so moving on. For 400, I can do 1 and 400. I could do 2 and 200. I could do 20 and 20. There we go. Same number, that's what I'm looking for. Which numbers have a factor pair made up of the same amount? So which two numbers did I have something where I got the same number? That was 100 and 200, or 100 and 400, sorry. Next, write multiplication sentences for those numbers showing the factor pairs made up of the same number. So we want to write these as multiplication problems. So what times what was 100? Well, that was 10 times 10. And then 20 times 20 gave me 400. Last question on this page, write these multiplication sentences as exponential equations. So I better see an exponent and I better see an equal sign if they want an equation. So 10 times 10 I can rewrite as 10 squared, which is 100. And 20 times 20 can be written as 20 squared, which is 400. Okay, please turn to page 59. On page 59 it says complete the sentences for each number. Now we're going to actually use the numbers from the previous page, so my 10 and 10 and my 20 and 20. So if 10 squared is 100, then the square root of 100 would be 10. So you just take your answer from when you squared it, that's going to be on the inside, and since 10 times 10 was 100, the square root of 100 is 10. So we also did 20 squared. 20 squared was 400. So that means the square root of 400 is 20. Which of the numbers are perfect squares? That was 100 and 400. So they were perfect squares because we used whole numbers multiplied by themselves to get that. Okay, next section, we want to solve expressions using square roots. So we're going to figure out what the product of square root of 9 times square root of 9 is. So the steps to do that, how can you rewrite the expression square root of 9 times square root of 9 using exponents? Well, I'm multiplying it by itself, so that means square root of 9 squared, since I see it twice. Is 9 a perfect square? So is there a whole number times itself that gives me 9? Yes. The square root of 9 is 3. So since the square root was a whole number, that's also what makes it a perfect square. Rewrite the expression square root of 9 times square root of 9 using the square root of 9. So I know that the square root of 9 is 3, so square root of 9 was 3. Square root of 9 is also 3, so that means 3 times 3. So all I did was I know square root of 9 was 3, wrote it. Square root of 9, 3, wrote it. Next, rewrite your expression using an exponent. So I have 3 times 3, which means 3 squared. Next, what is the value of your expression? Well, 3 squared, 3 times 3, that's 9. What is the result when a square root is multiplied by itself? So when we have a square root that's squared, we actually get the original number that we started with, so the original number. So anytime you see the square root of a number, but that number is being squared, the square root and the exponent too, they just cancel each other out, and you're left with just that number that was on the inside. So let's look at a few examples. The square root of 16. So what times itself is going to give me 16? That's 4. Because 4 times 4 is 16. Please do not put 8. I'm not dividing by 2. There's no 2 there, so don't divide by 2. Next, the square root of 10 squared. Well, 10 squared is 100. Square root of 100 is 10. So notice the square root and the exponent 2, they cancel each other out. I'm just left with what was on the inside. Next, square root of 25 times square root of 25. Well, again, that means square root of 225 squared. The square root and the exponent 2 cancel each other out. We're just left with 225. Okay, turning to page 60. And it looks like this is going to be our last page for this part of the workbook. Just 3 questions. What is the square root of 121? So square root 121. So what number times itself is 121? That's going to be 11. Next, square root of 8 times square root of 8. Well, that means square root of 8 squared. Square root and the exponent 2 cancel each other out to get 8. Number 3, what number So what's the square root of some number squared? It's going to be 15. Well, I know that the square root and the exponent cancel each other out to get what's left on the inside, so that's going to be 15 since my answer is 15. Okay, so now you are in charge of doing the independent practice on your own, which it looks like is pages 61 and 62. So go ahead and do those pages. When you're done with them, go ahead and put them away where they go in the classroom. If you have any questions, please let me know.